Good morning, everyone. Brice Martinot-Lagarde. I'm the Global Solution Architect of the Cloud and Service Provider segment. My job is developing reference architecture, developing skills with those reference architecture inside the company, and delivering all of this to you customers in order to organize technical workshop and exchange on the different issues and solution we can bring to solve the problem. So I'm gonna speak now about open compute. We work on the different standards, of course, but now I will concentrate on the open compute. And I will go fast in terms of introduction. Just a kind reminder about Facebook. So they started in 2009 developing their internal projects. And the idea was really to remove all the silos between all hardware you can find in a data center, from the grid to electrical distribution, to the conversion, to the cooling, and also including the servers, the storage, and the network equipment. So the main outcome of this project was to decrease the cost by 24% versus their standard design, and increase the efficiency by 38%. So I think from Rhonda introduction, we are exactly on the focus about what are the KPI, which takes care of all your business. So it has been created, Open Compute project has been created in 2011 by Rackspace, Facebook, Intel, and Goldman Sachs. And you can see here now, after a couple of years, that we have about 100 companies which have, let's say, taken the standard, or it is not really a standard, but at least the willing to standardize and simplify and be more efficient by building a data center. Another point which is interesting here is we have all the different type of companies. There are many type of companies, different type of business. That can be banks, that can be telecom equipment manufacturer, it's of course colocation, software vendors, IT manufacturer, and telecom operator as well. So everybody is looking or is involved inside the open compute. So open compute is really about efficiency. The first topic which is raised by Facebook is we want to be more efficient. We want to be more efficient, of course, in terms of energy efficiency, but not only, it's about efficiency on CapEx, efficiency on how we scale, it's efficiency about how we operate, and all this stuff brings the value of this project. It is one of the conditions, of course, for those companies is to be able to share ideas, share intellectual properties, and then at the end of the day, it's for doing innovation. They have split the project in 7 topics, and there are 3 topics related to the IT, one for servers, storage, and network equipment. There is one which is very key, and we'll see afterwards, it's about the racks. There is one related to the certification that companies they would like to put in place certification to be able to certify companies who wants to provide and deliver OCP equipment. And it's about the data center itself. Okay, so all the different hardware bricks you can find around the racks and the IT equipment. So if we look to another level of accuracy of what does that mean, this is the first big outcome of this project. Okay, you can see in this picture the traditional way of feeding the power to the IT equipment. By moving to OCP, it is changing a bit. You can see the first thing is to put 12 DC bus on the rack. The second thing is to feed through a PDU two power supply or power shelves and removing the UPS and putting all the conversion, the battery backup unit, and also the redundancy potentially, or the density of the rack inside the PSU. And then the servers is changing also. As mentioned by Rhonda, the servers are not the same. Okay, we have removed the fans inside the servers in this OCP servers, and we removed also the power supply unit, or the different power supply unit you have inside the servers. So we combine, from functional standpoint, it doesn't change anything. We still have a conversion, we still have backup battery unit, and everything feeds the electronics. But what is changing is we have concentrated all the power supply in one or two units, and all the conversion inside the electrical distribution has been removed. So no UPS are in this electrical distribution. So that changed a lot. In terms of benefits, of course, you can imagine that it gives a lot. It gives a lot because it removes all the silos, and it considers really how we can feed an electronic component. It's not about a server manufactured by a company. It's really what does that mean to feed the 12 volt to an electronic component. And then it is really about understanding all the different functions we need to put in place in order to feed that with a high scale. The second thing is about it reduces the AC-DC conversion. We only have one AC-DC conversion. And we feed directly DC conversion from the power supply to the electronic. It solves question about centralization, decentralization of the UPS, centralization, decentralization of the battery as well. So even if we can do the design differently, because actually the different companies who have adopted the open compute, they made their own, let's say, customization design. Some of them also think about a centralization battery unit, but this is a, let's say, a specific story according to one customer. Let's be a little bit more generic about the OCP. The second point is about what the rack server integration. So from mechanical standpoint, the fans from the servers have been removed and are concentrated on the rear door. You have a set of fans on the rear door, and all the ventilation of the servers are under the rear door fans. And so it removes different, let's say, stream inside the racks, and you have a much more efficiency. You have more reliability also, because the fans are optimized according to the density of the rack you want to handle. So at the end of the day, it's also a lot of benefits from business standpoint, because we speak about simplification, return of investment, higher reliability. It simplifies also the way to operate, because everything is standardized. And it also reduces the time to market, and it gives more efficiency thanks to the reduction also of the conversion you have into the electrical distribution. So it's all about improving the KPI on the business. Here you can find the different components we have, we can see in the market, which are available. So the servers and storage on the top right, the racks, the power shelf. The power shelf is a combination of the power supply plus the battery backup unit. And you have a picture of the integrated rack here. So, from once we have made this good stuff related to the different subsystem or product, what about the electrical architecture? So actually, we have today, we can find here on the left side, the traditional optimized two-end design. I know as colocation companies, you have made already some trade-off optimization of this two-end architecture. But if we stand with the assumption that we have a two-end distribution for most of the components, we have here what we call the optimization is about the genset centralization at medium voltage. And then we have a traditional distribution with low voltage gears, UPS, busways or cables, and then it goes down to the IT enclosure. On the right side with OCP, and because of Facebook, because of those main companies, they want also to have some kind of electrical distribution which reduce the number of equipment. And we spoke about the costs. Of course, with this type of design, you reduce drastically the costs because you have only one FED per rack. And all the low voltage distribution is also very much simplified. And because you don't have a redundancy from a low voltage standpoint, you can put your genset at low voltage, and it is also a way to minimize and reduce the capex of your overall architecture. So some figures, just to show you what does that mean concretely. Sorry, I'm doing fast. The first saving, of course, is about the redundancy differences, but not only. The second is about the costs. You need to add a little bit of cost of capex due to the type of rack, which is slightly different. Then you have 8% savings from eliminating the upstream UPS. Even if you had some additional features inside the rack, you're eliminating a lot of costs coming from the upstream UPS. Then we have an additional cost for the lithium-ion battery. And finally, we reduce also the cost due to the fact that we don't need anymore the power supply which are embedded inside the IT components. So at the end of the day, it's about 45% capex savings. It's a huge amount. And I'm sure that you are attracted by this figure. So that's good, but I think most of you are not Facebook, okay? It's obvious. You are not doing exactly this type of business. You are a colocation company. You are providing different type of services. And then you need to have and to mix different type of SLAs. SLAs is also about redundancy. It's also about availability of the system. So if we want to make the adoption of open compute, this is a kind of headache. So we have to propose as Schneider different option and flexibility and deliver the flexibility. So this is one proposal, and we think that there is no reason why colocation companies cannot be also an adopter of open compute. And at least if there is huge customers who ask for that, we need to be prepared as Schneider to deliver you some good ideas of doing that. From medium voltage standpoint, we don't want to change anything because we consider that the redundancy and the reliability of the architecture is key at this level. And even if you are building, let's say 5 megawatts, or between 3 to 5 and 7 megawatts of data center, you don't need maybe of course you don't need a medium voltage distribution, but from medium voltage substation standpoint, we still want to rely on 2N electrical distribution. Then let's take the first possibility. First possibility here is to have a mix of different powertrain. And what we would like to propose to the market as Schneider is to really standardize the low voltage powertrain. By developing different type of powertrain, it is, in our opinion, and we are ready to be challenged about that, of course. We think that it gives a lot of flexibility to mix the different SLAs and also to be more flexible related to the scalability. It's very difficult to understand at which speed the open compute will come. And then in case with this type of standardization of low voltage powertrain, it will help you, we think, very much to meet this requirement without taking risks in terms of CapEx. So here on the blue side, we have the traditional design. Okay, nothing changed. I think everybody's well understand this type of design. And here we can imagine that we have a very simplified powertrain, low voltage, which is 2N attached to the rack. Why 2N? As far as I understood, colocation companies host a lot of web giant companies. And those web giants are using the colocation for building their mesh down to the countries and the smaller, let's say, areas. And in the 20 years ago, we used to speak about front-end processor and back-end processor. Front-end, or now they call it hot and cold. So the hot is very close to the customers because they want a high SLA. They want to maintain the SLA as much as possible because this is a question of quality of service. And they are ready to pay for it. The backend is another story. So some of the backend processor and infrastructure can be handed over by another one because it's less real time. So I think you are pretty much aware than me on that story, but this is the idea. And with the 2N, first we have the benefit of the simplification of the low voltage powertrain, but we can still have a quite high level of SLA by using the open compute racks. Another option is to design a mix of single cord or dual cord attachment to the rack. So if there is a need of having a single cord attached inside the data center, we can, inside the same room, mix a different type of connection. So some of the condition is to maintain the power balance, so the load balance from an electrical standpoint at medium voltage. But we have a big customer inside, we are delivering a lot of things to them. They have a high requirement, which is to be able to have a difference of 40% of load balance between the A and the B. So in other words, if you think that it is not enough flexible, we can introduce some flexibility at the low voltage to be able to have this difference of load balance, or to avoid you to have some risk and control with a minimum of delta the difference of load between A and B. And the final, in case of a great adoption of the OCP, or if you have a big customer coming to you and say, I want to have 1,000 square meter only for me, then you can have a dedicated powertrain, AB, or single attach, that can be dedicated for a given customer. So now, if we make a very quick estimation of the differences between a standard 2N traditional, okay, it's 2N optimized, but it's 2N distribution, with an open compute 1N, 100%. With a hybrid solution, you can reach already a big number of savings. So here we have made a calculation for an open compute type of racks with 2N attached to the racks. So that gives an order of magnitude of the type of savings you can get with those solutions. So as Schneider, we can be challenged about the figures, but I think the most important things here is to understand the differences between the figures. So that's the takeaway for this presentation. So one thing is, of course, open compute has a lot of people and a lot of companies are following and are involved in this project and way of standardization and getting more efficiency on the hardware. So it is interesting. It's like a bit of we have open source for the software, so why not open compute and open source for the hardware? That's the idea. We think that there is no reason why colocation will not take a part of this business. That's no doubt from our perspective. And we are ready to give you the flexibility and to share with you anything we can do in terms of design, optimization, scalability, to be able to adopt this OCP and to give the flexibility according to the business you have on your colocation business. Thank you very much.